Hello everyone, welcome again for another session. So today we'll be covering what is a new mode in Istio, which is ambient mode. What it is, how it is different from the regular or the classic Istio, and how to get started with it. So without any further delay, let's get into the discussion. So in today's workshop, we'll be discussing like how to install Istio in ambient mode in Kubernetes cluster. So it is a real cluster we'll be working on directly. Then we'll be deploying two services and we'll be trying to access it from outside and within the cluster as well. Then we'll see how the traffic is moving from one service to the another service. And then we'll try to apply few policies and see how it works with the new design of Istio and where and all it is having its changes. Okay, so if you remember or if you know, like in classic Istio, what happens? In classic Istio, each and every service, let me start a pointer. Yeah. So in case of classic Istio, what happens? Each service will have a sidecar associated with it within the pod. So service A will have one proxy here, service B will have proxy here. Same goes with the another node. So here we are covering two nodes just for explanation. Service B again will have a proxy here. Service C will again have a proxy. So whenever a communication happens from service A to, let's say, service C, then the request from A, it leaves the container of application, then it goes to proxy container, and from proxy container to next proxy container, which is the service C proxy container, will be communicated, and the request will be forwarded back to the upstream, which is service C application. Same for the request, it goes in the reverse order. So that is the thing. So you imagine a situation where we have a lot of services and all those are Istio enabled. So suppose thousands or 2000 or any number. So in that case, what will happen? All 1000 or 2000 services will get one proxy each. Okay, and the disadvantage of that is, or it is needed sometimes, but as per that one, the main disadvantage of that is resource utilization. So what happens, you can imagine if it's having 1000 services, so all 1000 services will get a proxy associated with it, and it takes memory and CPU as well. Okay. And sometimes what happens, even it takes higher memory than the actual service. So we have seen for few of our clients that way, and it causes a trouble sometimes. So the new architecture of Istio, which is another data plane mode, which is called ambient data plane mode. In this case, what happens? The need of the proxy associated with each application has been removed. So that drastically reduces the cost of the resource, whether it's CPU or be it memory. What happens? Now the proxy has been broken into two parts in this mode. So one is called Z-tunnel and another is called Waypoint proxy. That we'll be discussing in the next slide. What is that? So Z-tunnel works at level 4, L4 level, and L7, if we want to do any processing further, like L7 processing, that there we need Waypoint proxy. But few of the cases or many of the cases, it is possible or it is not needed to do any L7 processing. In that case, only Z-tunnel is enough. And the Z-tunnel is daemon set. It means it runs only one, like one instance or one application, we can say, on each node. So you can see, like even the particular node is having lot many applications, even it is like thousands or 500, 100,000, doesn't matter. So it is now, it has reduced drastically, like 100 times if it is 100 application is there in one node. And it is having only one or two, like based on the load and all that we can configure. But let's imagine a situation like it will have a one, each node will have one proxy. So here it is Z-tunnel, and the Z-tunnel works at the level 4. So we can see like how it has reduced a lot of resources. That is one advantage. So in that case, what will happen if there's again the service A makes a request to service C, that request goes to ztunnel of node 1. From ztunnel of node 1 to ztunnel of node 2, that request is sent, and the communication between ztunnel to ztunnel from node 1 to node 2, it is encrypted, and that works like it's by default enabled. So you need not to do anything. As soon as you install and configure all those things, it is by default encrypted. So you need not to worry about anything doing specifically to enable MTLS. So all your traffic data communication between one node to another node, it's already encrypted. So from ztunnel of node 2 to C, that data will be flowing. That's a L4. That's the first component of the new data plane mode. Okay. Now we'll be going to the next slide. Waypoint. So that waypoint is needed only when we need a L7 processing. So any higher level of processing if need to be done, like authorization at method level, route level, all those things, then only we need, or any further like advanced processing kind of things, then only L7 is needed, which is achieved by the another component, that is waypoint proxy. So when we introduce a waypoint proxy, here we can see. So in that case, now if service A wants to make a communication to service C, and if waypoint is enabled, don't consider currently this one. I'll explain what is ABC and all. But yeah, so let's assume first it is only one waypoint. Okay, waypoint is having different ways to configure it. So service A. So now the request will go to ztunnel of node 1, and then from there it will go to waypoint proxy. From waypoint to ztunnel again of the particular node, and then it will go to service C. Okay, so now this waypoint, it works at 3 different levels. By default, when we enable waypoint proxy, it is enabled and it can be attached to a namespace. It means only one waypoint. Here you consider only one waypoint, and if that is considered for this namespace which is residing in C, like which the namespace on which the C is residing. So what will happen, or the reverse also, like if if one namespace is in the node 1, it is enabled, and if one waypoint proxy is attached here, then what will happen, all the requests from C to A or B, doesn't matter like how many services are there, that will go via the waypoint, all the requests, doesn't matter. So that is mode 1, like one way of configuring. So all the requests to a namespace will go via waypoint if it is configured to listen at the waypoint namespace level. Further down, there could be possibilities if you want not to enable all namespaces for all the services within the namespace. Few specific services only needs a waypoint. In that case, what will happen? We can even attach the waypoint to a specific service. So in that case, what will happen? All the other applications will get the request as it is, but only the specific service for which the name is for which the waypoint has been enabled, that will go via the waypoint for L7 processing or any advanced processing. Even it can go to further down, like even we can configure the waypoint to a particular deployment workload. It means pods. So even further down, if you want to do any specific processing for a specific workload, there also it can be attached. Okay, we'll be seeing that one. Okay, so now going to the next. Okay, so this is the kind of a brief architecture idea what I have given. I'm not going too deep into this session. If anyone needs any further or advanced kind of thing, definitely we are there always to help you out, reach out to us. Now we'll be directly jumping to the demo. What are the things we want to achieve in this? Okay. So we have already configured 2 clusters, but one for ambient, okay? And if time permits, we'll be showing the performance as well, like Istio sidecar mode and ambient, how the ambient is more performing than the sidecar model, okay? That we'll see. But yeah, first to get started, let's get into the installation first. Okay, so I have, let me go to the required directory. Okay, istio This istio is released, we can download. So this is the prerequisite. if we are installing with the command line istio-ctl. If we are going with the hem, that is different story. With the hem we can install as well. But for this session, I'll be covering the istio-ctl way. So istio-ctl, you can see it's the latest version 1.2.23.2. It's the latest release. I'll be using this one for this demo. So to install Istio in ambient mode, what we need to do is fire this command istio ctl install set profile is equal to ambient. Okay. What it does, it installs Istio core like CRDs and all will be there, CNI plus ztunnel. So ztunnel will be installed on each node that we'll see, that we can verify. So this cluster is having 2 nodes currently. Okay. 2 worker nodes are there. I'm installing, we can verify that. Within few seconds it will be done. It will not take much time. Okay, studio installed. That's a controller, CNI, and then ztunnel installed. Okay, let's verify. Okay, so we can verify here 2 ztunnel installed on each node. So I can verify that as well. kubectl get nodes. So we are having 2 nodes. Okay, and we can verify here both are having 1 ztunnel. Fine. So now the setup is ready. Now it's time to get started with the application and how it works. Okay, so we'll be deploying 2 demo application. Okay, both are having same echo server. Only the pod, when we deploy with the pod name, we'll be able to identify from which the application is coming. Each are having only 1 replica, so that we'll be able to identify from which pod or which service we are getting the response. Okay, so let's go ahead and deploy kubectl apply demo deployment 1. Okay, I'll be deploying both. So we can verify it's just having a deployment. Okay, it is having 1 echo server image. It doesn't just respond to a request whatever we are sending, and it is having 1 service. That's it. Okay, same goes for the other one. So now the application has been deployed. Now it's time to deploy a third application like Sleep. I'll be using to ping or to send a request, or I'll be trying to access from the outside also. Okay, so one thing is there for ambient mesh for L7 processing mainly, we need to have a gateway API specification or gateway API CRD installed. Okay, so let me just verify if it is already there. Get CRDs. Okay, okay, it's not installed. So let's install that. So we can install that directly from the website. We can type it here. Gateway API GitHub. Okay, it's loading. Anyway, we can directly go and download from here. Releases we can see. And the standard one currently what I have used is this one, the latest one. Okay. So we can see it is having a CRD. I'm using the standard one. Okay. For simplicity, what I did, I just downloaded it here in my local, and I'll be using that one to deploy. Apply -f. Okay. Okay. Keep still. As I deployed it later after the Istio, I need to restart that one. But so the way to install Istio is first you install gateway API specification CRD and then you install Istio. So I'll do restart, deploy Istio system so that Istio D gets the information about that. Fine. So now the application has been deployed. Now it's time to deploy another either application or the gateway from which we would be able to access the application. So I'll deploy both to make it work. So let me deploy sleep first. Sit here. And let me know if you guys have any question or if I'm going too fast. So this is sleep application. It doesn't do anything. It just waits, and we can exec into this application and try to curl any one of the applications. So I'll do the same thing. Kubectl get pods, and meanwhile I'll deploy this also. So this is again another. So this gateway, it comes from the new specification, which is modern specification from Kubernetes. So all the new ingresses, they follow this one. Okay, so if we want to migrate to the newer era or modern API gateways or gateway specification, this is the way. So, and ambient mesh uses that one. We'll be using that to deploy our gateway and HTTP route to route the traffic to the specific pod. I'll just explain here. It's a gateway. It once we deploy, it creates it deploys a kind of a pod or a ingress, okay, which will listen for the port 80. Okay. Then we need to have a HTTP route created. Again, this again comes from the gateway specification only. So one HTTP route for path 1, I have created echo 1, it will listen for, it will go to the deployment 1. Echo 2, it will go to the deployment 2. Okay. And if you are having only echo, then it will try to switch between those two, because I am directly having another service which is sending the traffic to both. Okay. So that we will see. So let me deploy. kubectl apply demo gateway. Fine. It will get the IP. kubectl get. Yeah, we got the IP. We would be able to curl this IP, or in the browser we would be able to access it. Let's see if it's up. Yeah. So we are able to access it. Okay. Echo 1, echo 2. Okay. So how the request, let's verify that quickly. How, from where we are getting that. Okay. So now let me go to the sleep one so that I can show that as well. Get pods. kubectl. Okay, so we can curl here. Again, it is one of the service we can send a request. Okay, we are getting the response from both the services, or even third endpoint also, third service. So what I will do, I'll make this one grep so that we know from where the request is coming. It will be easier for us to understand. Okay. So we can see it is toggling between these two. Okay. We can verify that as well. How many pods are there? Let me. So just remember the name at the end. It is 2s at the end and q, xq at the end for the another one. And we can verify here. Whenever I'm firing the request, it's toggling. Okay. And if I fire only to specific service, then it will get request from only the one. Where is that? Yeah, host name. 2s. Okay, it's always 2s. And if I fire the second one, always the xq. Okay, so for this one, we have not enabled ambient mesh yet. It is a default setup, whatever we did. So now it's time to onboard this application into the ambient mesh, and how simple it is, we'll be seeing. We'll be verifying as well what is happening. So for that, what I'll do, I'll first enable the access log so that we will be able to see how the communication and all is flowing, so that we know, okay, from where and what all, whether it's going really, whether it's eternal and all. So for that, I'll enable access log. So for that, what we can do, we can enable access log with the telemetry and with the issue system so that it gets enabled everywhere. So I'll just apply this kubectl enable access logs. Okay, now we'll be able to see logs. So what I'll do first, I'll start logging the ztunnel and we'll send a request to see whether it's going via ztunnel currently or not. Okay, kubectl logs nf-l. Okay, sorry, Istio system. And let me clear this one. Now I'll try to send a request. I'm just removing this one grep for now. Firing a couple of requests. Okay, we are seeing here request is going. Let me check it is Istio enabled already. kubectl get ns. So okay, that was enabled. That's why it is going. Okay, it's my bad. Let me do one thing. kubectl okay. So now let me clear this out. Now I will be sending few requests. Okay, to 1, to 2. Okay, both the services, and we are not seeing any logs here. Okay, no logs. It means it is not going via ztunnel currently. To onboard the application into the Istio ambient mode, what we need to do this, just we need to label the namespace. kubectl label namespace default, as my current application is all default. And then we need to write mode is equal to ambient. That's it. So all the application into the default namespace now onboarded to the ambient mode. It's Istio enabled. So all the communication now it should go via ztunnel, and all the communication now it will be encrypted. Okay, so we'll verify that one. But one point to note here, I want to emphasize that in case of Istio, classic Istio, where we had to have sidecars. So when we enable, like when the applications are running, existing applications, and when we try to onboard those applications to the Istio sidecar mode, in that case, when we label, we have to either label the namespace or into the deployments we need to inject. Okay. So the simplest way is to label the namespace similar to this one only. But in that case, what happens? Even if we label the namespace, by default, it is not onboarded. We need to restart the deployments. Then only when they restart, the new pods, in the pods, new container will be injected. The proxy container will be injected only if we need to restart. But here the advantage is we need not to restart the application. So it means your application will not see any kind of traffic interruptions. So it is just label it and it will just work as it is. Okay, that's one of the advantage worth noting. So now I'll send few requests. I sent just one request and we can see the logs are coming from the tunnel now. So now all the communications from application like sleep to the application, it's going via the tunnel. I sent for this one and then service 2 also I'll send and we see the logs. Okay. So this proves we have successfully onboarded the application into the ambient mode and all those things are working fine. Okay. Okay. So the next thing what we'll see is, okay, we onboarded. Now it's time for the next thing to see is authorization. How this authorization and all it works. Okay. So as I was mentioning in the diagram here, so we have L4 and L7. So we can apply authorization at both levels, L4 level and L7 level as well. L4 level is just kind of service directly, it will restrict the service. It will not have any other information. It cannot restrict a specific path, mode, or something like that, like path or the command or all those things. Rather, it restricts the complete application altogether. So in that case, how to apply, and that works at the regional level here. L7, when we apply the policy, that will get applied here. Okay. So this one, application one, like authorization policy I'm applying. Okay. This one, what it does, I'll just explain a bit. It is allowing service like application one to be accessible only from sleep one. Okay. I have not deployed, I'll deploy just the sleep one as well, and I'll try to access that application first. And then I'll apply this authorization policy so that we'll be able to know, okay, what had happened. Apply have sleep. Fine. So now it's time to have another tab. Okay, anyway, this one already we have verified, so I'll just close this one. Here. So I'll take this one now. I'll try to curl again with the same thing, same application. So the first one is only sleep, as I had opened it earlier. This one is sleep one. Here we can see the name also at the top. Okay, I'll curl both services and I should still be able to access it. Okay, both are working fine, perfectly fine. Now this, what this authorization policy does, it is telling that only sleep one should be allowed to access this application one. Okay, so from sleep one I would be able to access both. Okay, but from sleep application I'll not be able to access this application one. Okay, so let's see, let's apply. Okay, let's fire the request here for both. Okay, this service one I'm able to access, service 2 also I'm able to access. Okay, or when I fire the third one, which is toggling between those two, I am able to get both. Here we can see. Okay. Now it's time to test for the sleep one application, whether I'm able to access. So as I didn't do any rule modification for the service 2, still I'm able to access. Okay. Now let's try to access service 1. As we have applied the authorization policy to allow only sleep 1, it should fail now. Okay. So it's failing, it's not allowing. So this way we can restrict which application in our ecosystem or in our cluster we want to allow and which all we don't want to allow. Okay, so it's a kind of a security measures again, like if we have very critical or very secure application and we want to allow only specific services to be accessed by that one. So this is the authorization policy we need to apply. This is the way we need to do. Okay, we saw that one. And if I fire service only, so it will toggle, like one time it will fail, one time it should access. Yeah, you can see. So this is the authorization policy at level 4. We are not having any granular control here. So to demonstrate that one, we need to deploy authorization waypoint proxy. That will be. So first, let me clear this one so that I can showcase that. Delete. Okay, so the next policy is authorization at the higher level, L7 level. It means we can have methods as well, paths as well, all those things we can have. So currently what it is saying, now it is the reverse. I'm allowing sleep to access the service 1, okay, only get method. So any other method like post, delete, head and all those things should fail, okay. And sleep 1 as usual, like it will not be able to access this one at all, okay, service 1. One thing to mention or note here, if we are using L7 policy to get applied at and if waypoint proxy is not there, it will fail. It will deny all the requests. That is to fail safe mechanism. Okay, that's the thing. So the requirement for this is to have a waypoint proxy. I will deploy. So waypoint proxy is nothing but another gateway again. Okay, only the class name, the controller is changed. It's Istio Waypoint. In the gateway, it was Istio. So this is for the normal ingress. This class is for the waypoint. We'll deploy this one and then we'll try to how to onboard this waypoint that I will show, and after that we'll try to apply the L7 authorization policy. So let me apply kubectl apply. Simple as applying this one, or otherwise we can fire the command also, which just does the same thing. Apply f demo waypoint. Okay, we can verify that it should get created another pod. So we can see now we have a waypoint, but even if the waypoint has been created, by default, it will not listen to any traffic and all. Okay. That also we can verify. If you want to verify, we can verify that as well. So let me do. Okay, let me here only. CTL logs. Okay, so it's listening, it's ready, but it's not listening. It will not listen to anything. To verify that, okay, let me clear this one if I have already applied. Okay, and L7 also should not be there. Yeah, fine. Okay, so even if it is there already, but it will not have anything. It will not receive any traffic. Okay, I can fire with both, and we are not seeing any traffic. Okay, because it's not currently it's not onboarded to listen the request. Okay, so to onboard this one to listen the request, now we need to label the namespace. As I mentioned, we can label at different levels. So by default, or the maximum use case will be at the namespace level, we can enable it. So all the requests going to that particular namespace now will go via this waypoint. Okay, so for that, keeps it here, apply -f. No, sorry, label ns default istio.io. This time we need to tell use waypoint. Okay, so we are telling which particular waypoint. We can have multiple waypoints, as I said, based on the use case and all. Advanced use cases can have multiple waypoints based on the service, based on the workload, based on the namespace. Here we need to tell which namespace to be used. Even we can use waypoint in another namespace also. That is having another, like we need to label it one more label we need to apply, but that we can cover somewhere else. This is the simplest way to keep it simple because it's a get started. I'll keeping it simple. Okay, so waypoint, now we need to give the waypoint name. So the waypoint, whatever had been created, this is the name. So now as soon as we tell, okay, this label, now this namespace is labeled. So all the requests to this namespace will be forwarded to this waypoint. Okay, it's labeled now. And all the new requests, whenever we are firing the request, it should go via waypoint. Okay, you can see now traffic started flowing from another person as well. I'll fire few request. From here also I'll fire few request. Fine. You can see lot many requests. So now we introduced a new component, another component waypoint in between this eternal. So now it listens, it intercepts the request, and if anything, any policies to be applied, it applies, and then it forwards the request to the other destination. Okay, so now it's time to apply authorization policy at level 7, and we'll see how this works with the waypoint. So it's a kind of similar structure. I'm allowing service 1 to be accessed from only sleep, and that to only get method. Okay, other things should not be allowed. So let me apply this. F demo 7 authorization policy. Okay, it's applied. Now it's time for the test. So when I am firing the request from sleep only, the get should get allowed. Okay, by default it's get, but it's allowing. Now from sleep 1, let's try whether it's allowing that or not. Access denied. So all other applications will not be allowed. So only the sleep application, it is allowed. That to only get method. If I do post, for example, it will fail. Even if the service was allowed, but it was allowed only to do the get. Okay, not the other request. So that way we can restrict, even granularly control which application we want to allow and to what, to perform what. If some application we want to allow only the get thing, not the post or delete or patch or any other things, update, that we can restrict. Only fewer applications which is allowed to that can be allowed. Yeah. Let me clean it up. Delete. Fine. Okay, so I'll be deleting that waypoint as well so that we can test the performance. Keeps it here. 0. Fine. So all this cleaned up. I'll be using Fortio, okay, as a client. This is a load testing tool that we can use to test the latency and all. I'll be using that one to test our application and all, like how it is behaving. Okay, for that I'll just apply. Okay, so let me verify if we are still having that ambient enable. Okay, yeah, so default is already enabled with that. We'll be using that. Okay. Kubectl. Let me close all these things not needed now. Done with this. Okay. I'll forward this service, client service, to be accessed here. So from the browser, I can just fire the request for the load testing. I'll be sending request to either one of the pods. So similarly, I'll be testing for the other. So both the clusters having same configuration, and we'll be testing how this is performing. Port or what? 8080 to 80. This is with the ambient one. Currently, I'm forwarding. Okay, so I should be able to access it from the browser now. Localhost 8080 geo. Yeah. So what we can do now, one of the service we can send a request to see the performance. So directly I'm sending this. Nothing. It's for 30 seconds. 100 kps will start with this first. Okay, meanwhile, I'll try to set up the other cluster, which is webinar 2. Let me see if it is having anything. Okay. It is having one only deployment. So I'll be using the same one, Eco Server 1. I need to label it and then we need to restart. Kubectl label ns default. It's istio.io. Istio injection enabled. Okay, now as I mentioned, we need to restart. Okay. Istio injection. Is there any label mistake? Let me check. Let me verify it quickly if I'm doing some typo error. Okay, sorry. So in case of Istio, classic Istio, we need not to mention this istio.io. Sorry, I forgot that it is for ambient. Okay, so Istio injection is now, let's do that. Now we need to restart so that we should get pods. So now we are seeing 2. Once all get ready, we'll start testing. Meanwhile, we can see latency. Let me fire one more request. Meanwhile, okay. So we can see here 40 and this thing are ready. I'll be again port forwarding here. So that will be kubectl port forward. You see again it's client. It's yes, I'm using already 8080, so I'll be using 8081 for the Istio classic enable sidecar one. Okay, and I will be accessing this in another tab. Sorry, localhost 81. This is the one which is sidecar enabled. This is with the ambient enabled. Okay. So let's take one of the service. Echo server service 1. Same configuration we'll be keeping. 30. Was it 1000 request? 100 QPS, fine, same. Let's see how it's behaving. So it is making 100 query per second, 100 QPS with 10 connections, parallel connections, and for 30 seconds. So it's total 3000. Okay, so let's wait. So here we can see with the ambient one, P90 it's 0.57 millisecond, P99 latency is 1.8 millisecond, P99.9 it's 7.5 millisecond. Let's see how it's 47, 1.4. Let's me fire another request with the higher QPS. Then we'll be able to see the behavior. Okay, in the interest of time, let me reduce this to 10 seconds only. Make it 1000 request. Same thing here I'll do. Yeah, so here we can see the differences. P90 almost same, 0.68 millisecond. P99 is 2.05 millisecond we are getting. And in case of sidecar, it is 3.33 millisecond. So we can see the differences here with the only single application it's happening. We can imagine what happens with when it is having a lot of applications and all that's running. Okay, that with that, it comes to the end of the session. If you have any question at any point of time, feel free to contact at imesh.ai. Thank you very much for joining.